Hey everyone, welcome to this explainer. Today, we are going to completely dismantle the current obsession with massive system prompts. And honestly, we're going to introduce a revolutionary new primitive for AI agents. For a long time now, prompt libraries have basically acted like brittle incantations. You cross your fingers, whisper the right magic words, and just pray your agent doesn't completely break, right? And the problem is, they just fail to compound. So today, we're looking at a totally different approach, one that treats agent procedures as portable, optimizable software. So let's just dive right into this provocative reality. The status quo of just throwing more and more instructions at a model, it's completely broken. We've all done it, adding just one more rule, one more edge case to a massive master prompt. But as the source material makes incredibly clear, this approach is an absolute dead end. All right, here is our roadmap for today. We'll start with the context rot trap, then introduce agent skills as a new primitive, look at how SkillOpt trains text, and finally, how to build an autonomous foundation.
Starting with Section 1, the context rot trap, and why bigger windows really won't save you.
We've really got to start by understanding this lost-in-the-middle phenomenon that is silently breaking production agents right now. You see, context should be treated exactly like infrastructure teams treat RAM. It is a strictly, finite, incredibly expensive budget. It's not some hoarder's garage where you can just toss every random rule you can think of. There's this super naive expectation in the industry right now that a bigger context window automatically equals a smarter agent. But the reality? It's much harsher. Cramming in more instructions just leads to conflicting rules and silent degradation, where the agent literally just starts ignoring your guardrails.
If we look at the data, like from Chroma Research and others across 18 different frontier models, there is a steep U-curve drop-off in accuracy as the input grows. This absolutely proves that throwing 50,000 tokens into a massive 1 million token window still results in severe context rot. The model simply gets lost in the middle of its own instructions.
And that brings us to this crucial takeaway. Every single token you place in front of the model takes attention away from every other token. You absolutely cannot isolate a capability if you're just dumping the whole shebang into one prompt. This limitation is exactly what leads us to the solution.
Which brings us to Section 2, Agent Skills, a new primitive for portable, on-demand procedural memory.
To actually move past all the multi-agent hype and genuinely solve context rot, we need to use the agent skill. Instead of building these insanely complex, brittle networks of sub-agents that require agonizing CI/CD pipelines, an agent skill is beautifully simple. It's modular, portable software, usually literally just a folder containing a markdown file. But it provides true procedural memory. It tells the agent how to do something step by step, effectively turning a general-purpose agent into a hyper-specialist, but strictly on demand.
So how does it avoid context rot? Through progressive disclosure. This three-step lifecycle ensures your active context remains tiny while your available capability becomes, well, effectively unbounded. First, the agent only reads tiny 30-token descriptions of available skills at the start. Second, it matches that description to the user's current task. And third, actually only then does it load the full skill instructions into its context window. It's just incredibly efficient.
What's really fascinating here is how this flow proves the expertise lives entirely in the skills themselves, not the commoditized agent runtime. You can install one package of skills, and suddenly any compliant coding agent, whether we're talking Claude Code, Codex, or Gemini, gains those exact lifecycle capabilities. The intelligence is completely portable. The agent runtime? That's just the engine. Your skills are the actual durable asset.
Let's move on to Section 3, SkillOpt, training text through bounded updates and trajectory feedback.
Okay, so if skills are the new unit of software, how do we systematically improve them without just guessing? Well, what if we train text exactly like we train neural networks? Right now, when a prompt fails, a developer usually goes in, haphazardly rewrites some lines, and just crosses their fingers that they didn't break something else. But imagine if we could map familiar deep learning concepts directly to text-based edits to optimize our procedural memory.
Doing this translates a really novel concept into super familiar developer territory. It proves we can train a markdown file just like model parameters. In deep learning, you use gradients, learning rates, and validation checks. Well, in SkillOpt, we use trajectory-derived edit directions, textual edit budgets, which is basically a learning rate to bound the size of your edit, and held-out selection gates to actually validate the change. This perfectly illustrates the difference. Notice those ad hoc updates? Those are large, unstable semantic jumps that completely ruin previously working instructions. Contrast that with bounded edits. By limiting the edit budget, the system avoids those chaotic updates entirely.
It allows the skill document to smoothly descend toward optimal performance without catastrophic forgetting. It's a real game changer.
By rigorously looping through these 4 steps, SkillOpt ensures that rejected edits become negative feedback and only strict improvements are exported. Basically, an optimizer model looks at batches of successes and failures, proposes structured add, delete, or replace edits, and then tests them. If it doesn't strictly improve the score on a validation set, nope, it's rejected.
Tracing the full pipeline, you'll see this epoch-wise slow update mechanism, which, yeah, is a bit of a mouthful. But it simply means preserving long-horizon regularities without bloating the deployed skill. The rollout batches feed into the optimizer, batch-level merging resolves conflicting suggestions, and crucially, there's a rejected edit buffer. That means the system learns from its failed edits. It ensures it won't try the same bad idea twice while slowly consolidating those stable successes over time.
And this isn't just theory, guys. SkillOpt actually lifted the average no-skill accuracy by an astonishing 23.5 points on GPT 5.5 indirect chat. Across 52 evaluated cells spanning different benchmarks, it consistently proved to be a measurable, massive engineering breakthrough. You get huge performance gains, and the output is just a compact, auditable markdown file. You deploy it anywhere, 0 model weight changes required.
Finally, Section 4, the Autonomous Foundation and Scaling Organizational Intelligence.
Zooming out a bit, how do we actually use this primitive and optimization pipeline to build a strategic asset for your whole organization? Well, to avoid context debt, we have to stop hoping an LLM will magically interpret complex rules on the fly. Instead, we encode that logic into deterministic, pre-trained skills. The core principle here is to shift intelligence left. We have to stop bloating our descriptions with capitalized commands like always do this. The models literally just learn to ignore them, kind of like how we ignore pop-up-ats. Push that logic completely out of the prompt and into a version skill.
Comparing these approaches makes it so obvious why we need to move away from high-tax system prompts. Look, if you edit a system prompt, every single chat turn pays the context tax. It inevitably leads to instruction conflict. But if, say, your HR team builds a new onboarding skill, it dynamically loads only when needed. The failure mode is bounded, and the domain team can own it themselves without waiting on some central AI platform bottleneck.
By following these actionable best practices, honestly, any organization can start translating their unique institutional knowledge into an automated orchestration. Instead of using the context window as some sort of database to pass state around, use file message buses. Pin your skill dependencies, just like you would with regular software. And the absolute best way to start, just record an expert on your team doing their job for an hour. That transcript? That is your first draft of a brand new skill.
Eventually, once you have a working manual loop going, you'll reach this meta skills territory, where the agent proposes its own revisions. But notice the flow here. It is heavily guarded by evaluation suites and human spot checks to prevent any regression. If an agent completes a task successfully, it proposes a new draft skill. You review it, you spot check it, and then you promote it. The agent is helping write the software, but your rigorous gating keeps the library pristine.
And that brings us to our ultimate takeaway. Your unique workflows, your heuristics, your domain knowledge, they just don't have to be trapped in brittle prompt libraries anymore. They can be trained, they can be evaluated, and they can be reused as true procedural memory. So what is stopping you from building your own autonomous foundation today? Thank you so much for joining me for this explainer. I hope this completely changes how you look at agentic architecture. See you next time.